Hello, I'm Kevin Dangor, and this is my talk from One Dev Day Detroit, November 15th, 2014. I assume not everybody was there, so I'm making a screencast version of it. I work on Brackets for Adobe. Brackets is a modern open source text editor specifically geared towards web designers. A bit more about Brackets is that it's MIT licensed open source, sponsored by Adobe, but there are hundreds of contributors and a number of non-Adobe committers. It's currently the 13th most starred project on GitHub with nearly 20,000 stars, and there are hundreds of extensions available. And just a few days ago, as of this recording, we released 1.0 of Brackets, and we also released an add-on for Brackets called Extract. And Extract for Brackets is really cool because it lets you take assets out of PSD files and really quickly get them into your web projects. So this is a screenshot of Brackets. Gives you an idea of what it looks like. For this talk, I'm going to be focused specifically on this part of Brackets, the file tree, because we revamped that to work with React, to be built on React. And the module that manages this is something called projectmanager.js. So I'm going to start by taking a look at a function in projectmanager.js. This particular function, document selection focus change, the purpose of this function is basically when the document changes in the editor area, we want to make sure that it synchronizes up with the file tree, so that the selected file in the file tree should show you what's currently in the editing area. So starting with this function, first thing I'll point out is that it uses a function and state from another module. So already when it comes to sort of testing and reasoning about what this function is going to do, you've already got another module involved in that. Expanding our context a bit more, we can see that not only do we pull stuff from another module, we're also pulling stuff from the DOM using jQuery. So we're pulling out these list items, and then we go and pull data off of those list items. These are actually model objects, things that represent files. We actually store those on the DOM nodes that represent the items in the file tree. So I should note also, this is the old version of this code. We'll see in a few minutes what the new version looks like. So expanding our context once more, we can see that if we want to know whether a given tree node is closed or if it's selected, we actually get that information by looking at classes on the tree. So we don't have a separate model that's keeping track of that for us. We're actually just pulling it straight from the tree. So now if we take a look inside that if block, I'll just point to this comment down here. So basically we're passing events through the JS tree itself, through that tree object, and that's how we communicate what's going on with the tree. So this is a third-party module, jQuery JS tree, and one more thing that complicates this is that basically the events that this relies on for how it operates also relies on jQuery JS tree to operate. So if something doesn't work quite the way we expect, which is sort of what this comment is alluding to, then that means that we've got to deal with it, and we've got to kind of work around it and debug it and all that stuff. So I'll note that this module, when I started working on it on the revamp, basically this had a handful of functional tests, and that's it, because it's really hard to test something that integrates state from another module, the DOM, model objects on the DOM, this third-party library that has its own view of how the world is going to work. So tracking down bugs is hard, fixing bugs is hard, and writing tests is hard. So I'm going to recommend this talk. If you haven't seen it, Simple Made Easy by Rich Hickey. It is an awesome talk. It is well worth the hour that you would spend watching it. But I'm going to take a couple of things from Rich's talk because I think they're a useful way to think about how we're going to make things better. So Rich gives us a couple of definitions in his talk. One of them is simple. And basically the definition of simple is it's composed of one thing, not combined. Okay, just one thing. And complex is an archaic word that Rich brought back to life as sort of the opposite, because you're interweaving things when you complex them. And so if we look back at this code, it might seem simple because, yeah, we're all used to working with jQuery and things like that after years, but No, it's actually not simple because it complex the problem of changing the document that's selected in the tree by interweaving these other modules, the DOM, basic model objects. It interweaves all of these different concerns into this one function. And so this is not a simple function. Another useful definition from Rich's talk is easy, because his talk was simple made easy. And the easy part is near at hand. Excuse me, near at hand. What he means by that is that, it's the obvious thing that you're going to do. The thing that's, when you pick up the tools and the language that you have, you say, yes, it makes sense. This is what I'm going to do. And so if you make it easy to do things the simple, non-interweaved way, then that's the way people will do it. React is one of those tools that makes simplicity easier, and it helps with the idea of keeping as much of the code functional as possible. So React is one way that simple can become easy in JavaScript. And we'll get to React a bit more in a couple of minutes, but I'm going to talk about the structure in general. So another talk that I recommend is Gary Bernhardt's Boundaries talk. This is a great talk. It's half the length of Rich's, so if you're limited on time, you might go and check out Boundaries. But it's got a different feel to it. And Gary's talk, he actually goes through some example code, which is nice. But one of the things that he brings up is this notion of having a functional core, and he calls it an imperative shell, but I like to call it an integration shell. And the idea is that you make the bulk of your program pure functions. So they take input, they give back output, they have no side effects as much as possible. And you use the integration shell, this one outer part, to basically talk to the rest of the system. So the idea is that most of your code is functional, most of your code is easy to test, easy to reason about, and then the parts that have to integrate with the other parts of the system are also pretty easy to reason about, because all they're responsible for is the integration piece. So they basically will have few lines of code and very few, if any, branches. So it's extremely easy to just read through that code and say, oh, okay, I see what this is doing. And if a bug happens to be in that area, you can pretty easily spot it. So looking back at the old document selection focus change function, this is what we had, just one piece of it. This is the entirety of the new function that replaced it. It still has a branch in it, so that's not ideal, but at least it's simple code. And really, again, this is actually now just about integrating the different pieces, finding out what the current file is and seeing if setting that to what's selected, and then basically signaling a change that other modules will listen to. So this really is just about integration. It's very easy to read and easy to reason about. So when it comes to application architecture, the Facebook people who gave us React, some of them have also given us the Flux architecture. That's the term that they use. Now you'll see in my examples that I give, I'm going to talk about the action creator. So an action creator is a term from Flux. I'm not going to get into Flux though, because it turned out that I didn't need it in the work I was doing. So I didn't go the whole way in creating Flux. Andre Medeiros, he outlines a structure he calls model view intent, and it's very similar to Flux in many ways, but there's some differences in terms of how data flows. And I'll just say that at this point, React really changes the way you can think about how you build your applications in JavaScript. And so I think there's a lot of experimentation that's still going on in terms of how people want to architect their applications. And of course, it's not always a one-size-fits-all thing. Sometimes one structure works for one application and not for another. Brackets, I think, is kind of unique among JavaScript applications, and that it's not like a single page application that pulls data from a database on the server. It's not like that. It's a long-lived desktop application that keeps its own state and has quite a bit of state to manage. So the structure that I ended up with is one that like Flux and model view intent has a unidirectional data flow, and I think that's one of the key things here that does keep things easy to think about. And that is that basically the project model manages this file tree view model, which is immutable, and I'll certainly talk about that later on. And when that changes, it sends a message to the tree to re-render, and anytime a an event comes in, a UI event, that goes to the action creator, which then causes updates in the model, which then will cause a re-render. So it becomes a very simple flow. You don't have messages kind of going back and forth between things. So now I'm going to talk about the React part of this and give you a feel for what our React components look like. So one of the things also I'll mention is that Brackets is currently using React 0.11, and 0.12 has changed the APIs a little bit. So the concepts are still the same, but some of the names of these methods that you'll see called are different. So just keep that in mind. But the actual one thing also I'll point out about these the code that I'm going to show you is that the details of the code are not super important. I've actually eliminated good chunks of the code in my examples, but the purpose is basically to show you just how things are structured and the general flow. So basically this is the render function that we have. It's responsible for calling React.render component. And basically when I talk about this sort of functional core integration shell idea, that's really kind of an effect here too, because file tree view is my React component for that file tree view. And it is responsible as sort of as a function. It gets passed all this input, mostly the tree data model and then some other things, and it returns a representation of what the UI is going to look like. So it really is just a function. And React.render component is responsible for taking the result of that function and integrating it with the real DOM by basically applying that to an element on the page. So the UI that comes out of file tree view will become the new contents of that element that is passed in here. So the way React works is when you generate these components, and this tree of components basically represents the DOM that you want to generate. But it is not actually DOM objects. It generates a virtual DOM. So they're lightweight JavaScript objects. It's very quick to create them. They're, again, very light. And what it does is you make a pass through here and create all the components. The next time you go through and render all those components out, it's going to do a diff of the old DOM and the new DOM, the old virtual DOM and the new virtual DOM. And whatever the changes are between those two virtual DOMs, it's going to apply that to the real DOM, which turned out to be very efficient and very fast. But one thing I'll say is that there are times that maybe you don't want to call render, or you don't want to re-render everything because you want to get a bit more speed. So React provides a hook called should_component_update, and you can basically short circuit the rendering process if you know that you don't need to render a component. And in this case, since I'm using immutable objects that we'll talk about later, that means that I can just compare the old data to the new data. And if there's no change, then we don't need to recurse down into our file tree at all because there's been no change. So it becomes really easy to write a should_component_update that will short circuit the whole render process. So speaking of rendering, React components all have a render function that are responsible for creating the additional virtual DOM that's needed to represent your UI. So in this case, the file tree view is going to render directory contents. So that's going to give us the top level directory of files and directories. And then it takes that and a few other components that I'm not going to get into, and it renders that into a dom.div. So React basically provides components that represent all of the basic DOM nodes. This part has changed a bit in React 0.12, but it's pretty simple. We're just building up a DOM here. One of the things I'll note also is that React has a simple extension to JavaScript called JSX, and JSX makes this code a bit easier to read, a bit prettier. But Brackets itself doesn't have the tools to deal with JSX right now, and it was easier to just use plain old JavaScript. And you can see that JavaScript is still pretty readable. It's when we call directory contents, or we call dom.div, I guess when you're creating a div, this is a way to think about it. That null for the first parameter is where the attributes would go, and you just pass that as an object. And then everything else is just children of that div. So it's very straightforward. So taking a look now at the directory contents component, one of the things that was nice about this, React is basically just your view layer, right? And since I could generate any DOM I needed, I could basically generate a DOM that looked very much like the DOM that was created by JSTree. And so I could also apply class names that were the same as JSTree. So the nice thing about doing this work, I was busy retooling the entire insides of that file tree, but I didn't have to worry about the styling at all because I could just apply the same DOM and the same classes and basically use the same style sheet. And something else I can mention in here is that when you're sorting, sorting could potentially get expensive if you're doing it a lot. Every time there's any little change anywhere in the tree, if we had to resort all of the elements in the tree, that might get expensive. But because we can short circuit that, because we have immutable objects, that means that sorting in the render function is really not a big deal. So this is the next part of the directory contents. Basically, the directory contents are going to be represented as a UL, so it's an unordered list. And this is a pretty common thing, in a sort of functional context. We have this list of names in order, and we just map across those. And for each one, we're going to generate a subcomponent that is going to go into this UL. And it's either going to be a file node or a directory node, depending on what that given entry is. Now, one of the things React does in order to keep track of stuff in a list and be able to recognize that a given element in the list has changed or has moved or has gone away is it uses this key. So you give it a key that's unique to that particular list, and it will use that to manage the list in the real DOM. So now we dig into the directory node. Now I'll talk a little bit about how React manages state. Because state is one of those things that can become a real pain point for your application, for understanding it, reasoning about it. And React supports the notion of state in addition to props. So props are these things that you pass in. You can see us referring to props in that directory rename input down there. We're passing along props that this particular directory node is getting. So props are basically like arguments to a function. State is basically like the state in a given object. So the idea behind state is that they envisioned that something that is strictly part of the UI, that is state of stuff that is going on with the user interaction right now, that kind of state you could store it right on the node, right in the directory node, right in your React component. I decided not to do that. I decided to just put it all in props so that it's in one place that I can manage and understand and reason about. And so, for example, in this particular case, in brackets, if you click on a directory name twice slowly, or right-click on it and select rename, it'll go into a rename mode, which lets you change the name of the directory right there in the tree. And when you do that, I could have put that as state in here, right in the directory node, but instead, that's done in the view model. It actually looks in the view model and says, okay, is there a rename flag on this particular entry? And if there is, I'm going to render the directory rename input rather than just the one that lists the name. So continuing on with how this renders, you can see that it's going to return an li component. So it's just a list item. Each directory node and each file node just represents list items. But I will mention how React handles events here, and we'll get into that. Basically, it's just like the old style where you're, in the DOM, when you're writing your HTML, you could actually say onClick. So in here, we're saying onClick, but we're not passing it a string because this is all in JavaScript land. So we can actually say just onClick is going to call this .handleClick. And the nice thing about the way this works is that React automatically binds your component's functions so that this .handleClick will have an appropriate this when that method is called. So let's take a look at handleClick. So it gets passed an event object, and of course React, being a modern library, it will normalize the event for you. It automatically handles that. Another nice thing is that it does event delegation automatically for you. So it looks like we're applying a click handler on each li, but we're not. We're just applying a click handler or at the top level, and then whenever the click events come in, React will delegate that to the correct component. This did actually trip me up while working on this, because we had a jQuery handler that was listening a bit farther down in the DOM, and so that jQuery click handler was actually picking up the event before this one. So it kind of feels like this one should get it first because it's down there on the LI itself, right on that directory node. But it's not really. The handler is up higher. Generally speaking, since you control, where your events are and what's causing your events to get picked up one way or another, it's usually not going to be a problem. It is one nice thing about React, though, that it does blend into one part of a page very easily. So now we see the use of this.props.actions. So basically, when you click on a directory, or in this case, you can see that there's an if blocker on here. So if we're Control-Alt-click on a directory, what it's going to do is it's going to, if that directory is already, if it's closed, it's going to open that directory and open all of its immediate children. And the way that it does that is by calling this.props.actions.toggle subdirectories. Now, this is the action creator that I was talking about. If we're doing full Flux, there would be a dispatcher involved, but in this case there isn't, and we'll take a look at what happens when you call that toggle subdirectories. So toggle subdirectories is back in our project manager.js, so this is sort of the integration code. And what it does, it just basically delegates to toggle subdirectories on the project model. But then at the end, you can see that that's going to return a promise because there's some asynchronous activity there. And it's going to call save tree state because we save the open and close state of all of the directories in your project in brackets. So whenever you open directories or close directories, we call save tree state. And that happens in this little piece of integration code. So remember how I talked about there being a functional core to this? Well, here is part of that functional core. And you might look at this and say, wait a minute, that's not a function, that's a method because it's on project-model.prototype. And technically speaking, you're right. It is a method and not a function. But one thing I'll say is that the real idea here is to minimize the side effects, to understand where your side effects are. And a method could be thought of as nothing more than a function that's been partially applied. So partial application of functions is basically where some of the arguments of the function, where you have a new function where some of the arguments of the function are automatically passed in. And in this case, the object itself, is automatically passed in. So that bit of state is passed in. I think if I were to do this again, I might actually do this a little differently to be more pure, more functional. But we'll see in a moment that there was actually a place where this was handy. So now we're looking at set directory open. This is the one that's actually responsible for opening a particular directory. The file tree view model makes an appearance here. We can see that it's kind of a partner in this operation, and that it has the information about what in the tree is open, what in the tree is already loaded. Because obviously whenever we open a new directory for the first time, we're going to have to read off the disk, the list of files, and so the view model is path loaded is what's going to tell you synchronously, do we already know about this? And the place that I had said where it's useful that project model happens to be an object is right here. Basically, this get directory contents is a small wrapper around the actual file system operation. And because it's a method on this object, when writing a unit test for this, it was really easy to basically just override that particular method so that I could return whatever directory contents I want without having to hit the disk. That proved to be very useful in testing, and we'll see why in just a moment. So once the directory contents come in, the first thing that we're going to need to do basically is take those contents and pass them along to the view model, and the view model will then take those directory contents and update itself so that there's a correct view that's going to be displayed in the tree. And that bit that I said about being able to override the get directory contents, this is why it's useful. We can see in here that we've got 3 different branches going on. I mean, there are a number of different branches in this code. So being able to test, to write unit tests for that code without having to actually put files on disk and do real disk I/O and everything was very nice. This code has a lot of unit tests now, actually. It went from no unit tests and a handful of functional tests to a lot of unit tests that run basically instantly. They're super fast because there's no disk I/O going on. So now let's take a look at the file tree view model. And this gets interesting because the file tree view model is basically immutable. There's immutable data that is at the core of this. So you can see this open path method on file tree view model. It's calling an open path function, and that function is pure. It actually has no side effects. And then once the result of that function comes in, it calls commit. So we will take a look at commit a little bit later. We'll start by talking a bit more about immutability and how that affects how we write our code. So working with immutable data is quite a bit different from what you're used to. So this is what our object structure looks like, basically. So we've got a subdirectory, and then subdirectory, and then third sub inside of there. And so we end up with this kind of JavaScript structure. So subdir can have properties like open, and then it's got children, and the children object has keys that it's the name of the file, and the value is an object representing that file or directory's metadata. And so if we wanted to open that third subdirectory, when you're using mutable objects, it's really easy. You just say treedata.subdir.subsubdir.open equals true, and then you do the same thing for third sub. Very simple. So this is in an immutable world. If we pick up that third sub object and we say third sub.set open to true, that's actually going to return a new object. It doesn't change third sub in place. That means that the third sub that's in our tree has not changed. The tree data hasn't changed in any way. And so what we're actually getting back, anytime you change something in an object, you get back a new object. Now you're probably thinking, wait a minute, if I'm going to clone something every time you create a new object, or sorry, every time you change an object, that can't be very fast or memory efficient, right? Well, it turns out it can be if you use a sufficiently smart immutable library. And basically, Facebook has created a library called immutable-js, and there's also the Mori library, which is a compiled version of Clojure's persistent data structures. They call them persistent data structures because immutable can sometimes sound funny. But basically, in both these cases, immutable.js and Mori, they both efficiently return objects that share. They do structural sharing with the original object. So as much as possible, they share the data with the old version of the object. Now, if you think about that for a moment, with a capability like that, to share data between versions of an object, that actually means that you could potentially hang on to previous versions of the state. And if you have something like React, where you just hand it your state and it hands you back a UI, that means that implementing undo for an application that needs that becomes just as simple as remembering the old state, going back to a previous state, and just calling React's render component with that old state. It's really quite cool. And that's just one of the many advantages. There are actually a number of advantages to immutable objects. So going back to our example, we changed third sub so it was open, and we got a new copy of that. So what we really need to do, it seems like, is we need to then take that new third sub that we got and set that on subdir, which will then give us a new subdir. And then we need to set that new subdir on subdir. And then we need to set that new subdir on tree data. And that is actually what you need to do. This is what needs to happen, is that we need to bubble that change all the way up to the top level. And this is why in our should component update, in our tree, we could actually just look at the very top level of the tree and say, did the tree data change? Is this the same object as we had before? And if it's the same object as we had before, then we know the data didn't change anywhere in that tree, and we don't need to render any of it. Now this looks a bit unwieldy, this bit of code here, and of course that is unwieldy. And so immutable.js offers update in and set in methods that basically do this. You give it a path and it will set something deep down in your tree and handle this bubbling up effect for you. So looking at OpenPath, this is the function OpenPath, and basically it takes in tree data and a file path. Now the first thing that we have is a convenience function called filePath to objectPath, and basically what it does, it takes like subdir slash subsubdir slash third sub and turns it into subdir, comma children, comma subsubdir, comma children, comma third sub. So that gives it the ability to walk through the objects, and it just returns an array. And that array will get passed to treedata.updateIn, and with the proper ability to open it. So that will actually then open it up, and we start basically at the deepest level in the tree, and we open that up, and then we work our way back up by popping from the object path. Now, here I am talking about all these great things about how immutable data is awesome and all this, but here I am using a mutable object path. It's an array, and I'm popping stuff from it. And as far as I'm concerned, that's okay, because object path exists only in this function right here. So I don't have to worry about some piece of code in a far off land changing that object path in ways that I don't expect. That can happen when you pass objects around through a big system, but that's not going to happen in this one function. So it's perfectly legit to me to use mutable objects in a case like this, and it's certainly convenient to do so. So this function has no side effects, and that means that what it does is it changes the tree data, having opened up the right directories, and it returns the new tree data. So going back to the OpenPath method, we can see that it's called that. It gets the new tree data back, and then we pass that new tree data to commit. And the commit method, it looks like this. First, it checks to see if the data is actually changed, and if it has, it's going to set that tree data on the file tree view model. So this is the point at which we are actually saying the state of the world has changed. And file tree view model, this object, is where we're keeping that state of the world. So this is nice because it means that we have we basically have bottlenecked or kept all of our side effects as far as like the mutation of this data in this one method, which is really handy. And anytime that data changes, we trigger a change event, and that is how our re-rendering happens. This is that unidirectional flow we were talking about. So we started with Control-Alt-clicking on a directory node, and then that passed through the action creator to here, which triggers an event, which is then going to cause re-rendering, and it just goes through a loop like that. So this is a great quote. I'm not sure how many people have seen it, but certainly is worth looking at if you haven't. Tony Hoare said, "There are two ways of constructing a software design. One way is to make it so simple that there are obviously no deficiencies, and the other way is to make it so complicated that there are no obvious deficiencies. And in the first method is far more difficult." That's the key point, is that we want things to be simple, but it can be hard to make things simple. So is the new code that I just showed you, is that simple? Well, you might not think it's simple because there are a bunch of new concepts, and there were a string of functions that get called in that sort of loop between rendering and updating the project model and all that. But I argue that it's definitely way, way simpler than what we had before, because each piece that I showed you had its own distinct responsibility. It wasn't intertwined with the other pieces, and that's why it's easy to test and easy to reason about. Any of the bugs that have come up, it's been very easy to just surgically go in there, change a few lines of code, add a few lines of test, actually do it the other way around. Write a few lines of test, watch it fail, and then fix a few lines of code, and then it works. This code I don't think has reached peak simplicity yet, but I think it's definitely a big step in the right direction. So if you're looking for something good to read, Out of the Tar Pit from 2006 is a really good readable paper. Basically, Fred Brooks talked about accidental and essential complexity in problems. Basically, the essential complexity of working on our software systems is is basically the complexity that our customers have, like the things that make their problems that they're trying to solve complex and difficult. Accidental complexity is the stuff that we as software developers have to deal with beyond just that. So if you think about, I need this to be multi-threaded, and so then I need to have mutexes and stuff like that. If that's accidental complexity, ideally we wouldn't have to think about accidental complexity kinds of things at all. And so we want to reduce that as much as possible. And this paper goes through a whole bunch of ways that we develop software and how that introduces accidental complexity, and basically comes to the conclusion that if we write most of our code, if we do functional programming for most of our code as much as possible, and we use COD's relational model of data, meaning if you think about like a relational database, use some kind of relational data store in your program as the place in which you store your state. This makes your program a lot easier to reason about, and I think that's right. I mean, I think in this case, file tree view model is sort of our transactional data store. Because of that commit method, if anything ever got into an invalid state, it's nice because it would never get committed. But it's not actually a relational data store. I think that's okay in file tree view model's case because it is actually hierarchical data. It's a tree, so that's kind of okay. But I think if I was developing other kinds of systems, I actually would like to have a relational store. I think that'd be cool. You can check out, there's a project called DataScript. You might want to check that out because it's definitely taking some of these ideas and putting it to work. So to summarize, a simple architecture, and the simpler architecture that we've got now in this part of brackets. Each part does one thing with side effects in a few known places. React is great because it lets you generate your whole UI functionally. It really simplifies what you have to think about. Immutable-js is awesome because it allows you to control when data updates occur. Every part of your application can have a consistent state, because again you're controlling where the updates occur, so nothing is going to change the data. Nothing in a far-flung piece of the system is going to change the data. And object identity can tell you when something has changed, is a nice side effect. So in the case of React, if you're using immutable data, your React updates can be super fast. So thank you for watching. If you want to learn more about brackets, go to brackets.io. The code is all up on GitHub, and I look forward to hearing your feedback. Thanks.